In this video, we are going to solve this particular question, and specifically, there was some controversy regarding this. So, I choose to solve this one. So, let's get into the solution of this problem. So, this method says that there is a mass m2 which is revolving around a bigger mass m1. So this m1, and the condition is m1 is much greater than m2. Now it says that this m2 is going to lose some mass, and that lost mass is going to get absorbed on this m1. So what will happen, this is a standard process, when a object is moving around a black hole. It so happens that because of the high gravity of the black hole, the smaller mass starts breaking down into small fragments, and those fragments start spiraling, and they are going to move in this m1. So this is how a mass is being dissolved. A mass is being dissolved in a black hole. So this is m2, this is m1. So because of the high gravity of this black hole, this will get fragmented into pieces, and then these pieces will start spiraling, and suddenly they will come into the event horizon of this black hole, and so on. But this is just a story which is certainly not related to the uh, answer to this particular question. Well, so this question has been asked in JE 25. So yeah, so this says that we are supposed to, so let's say at a particular time, this is the particular distance between the m1 and m2. Okay, so we are asked to find out this 1 by r dr over dt, and we have to find out this, and what we are given with that this dm2 dt is equal to minus gamma, and dm1 dt is equal to gamma. Yeah, so this is the two things. So this m2 will get divided into fragments, and those fragments are going to land up on m1, and that's how the mass of m2 will decrease and m1 will increase as time goes along. Yeah, so okay, yeah, so one thing that is going to happen is that the angular momentum of the system is going to get conserved, because there is no other way. So if this angular momentum of the system is equal to angular momentum of m1 plus angular momentum of m2, yeah, so this is true because this is going to happen. So the angular momentum of the system is going to get conserved because there is no external force acting on the two objects. Okay, so yeah, so this thing is going to get conserved. Yeah, so what will happen then? Okay, so what is the L m1 vector? This is 0, right? Because this object will be in stationary motion. Like there will be no motion of this m2 because it's much heavier than m1. Otherwise there would be a classic rotation between this m1 and m2. In that case, m2 will also be rotating around m1. Yeah, but as m2 is much m1 is much heavier than m2, so there will be no effective rotation of this m1, so we can consider this as a stationary object. Yeah, so this is 0, so L system is nothing but L m2. Yeah, so let's say at this particular instant the velocity of this m2 is v, this one. Yeah, so the angular momentum, so this angular momentum is going to be m2 v into the distance between the two, and what will be the direction if this this direction, let's say this direction is k cap, so this is into the plane of this particular figure. So yeah, so r cross p, so this is the r vector, r hat, this is the p hat, p hat is the momentum, so r cross p is into the plane, so this is k hat. Okay, so this is the L sys. Okay, yeah. Now this is the thing. So now at this particular instant there will be a gravitational pull on m2 due to this m1, and that's why we can write that m2v square divided by r is equal to g m1 m2 divided by r squared. So this gravity between the m1 and m2 will provide the centripetal force to this m2 to move in a circle. Yeah. So it says that it moves in a circular orbit, so that's why you are able to use this equation. So yeah. So now what will happen? So if we solve this equation in a while, so we will get that okay. So v square is equal to g m1 divided by r. Okay. Yeah. So v is nothing but g m1 divided by r, and there will be a square root on this. So this else vector is equal to m2 v, and in place of v we can substitute g m1 divided by r, and there is a r and then there is a k hat. Okay, so this is the angular momentum of the system. Else if I simplify this, what will happen? This will be m2 r to the power half, and then g to the power half, and m1 to the power half, and then k hat. Okay. Okay. So so this is the vector of that. So now I can, from this I can switch. So one thing I know, that this dl dt, this has to be equal to 0, because there is no external force acting, external torque acting on the system, so the angular momentum will remain conserved. Whatever you do doesn't matter. So this will be equal to 0, but like this is along a single direction, so I can, so from this will conclude that, so so this L system can be written as L sys k hat. So this dl sys dt vector is like dl sys dt k hat plus L sys dk hat dt. So because this is a classic situation where there is a chance that the vector will also switch the direction, and that can also introduce a derivative of this else, right? Because if the angular momentum switches direction, so this term would have been contributed, but this is 0 here because your k hat is not changing all the time. The angular momentum is pointing towards the in the plane, so you can just get rid of this term. So your dl sys dt, this vector, is equal to dl sys dt and k hat. Okay, so you can drop down this so now you have this thing, right? So to compute this dl sys dt, you just have to take the derivative on the magnitude. You don't care about the direction. So now you have your L sys is equal to what? G to the power half. Okay, g to the power half m2 m1 to the power half r to the power half. Okay, so now you take a log. So log of L sys is equal to half log g plus log m2 plus half log m1 plus half log r. So you will just we have to have this form, right? Dr dt. So this form will indicate that you have to take a log. Okay, so this will be 1 upon L sys dl sys dt, and this is equal to 0 because this is a constant term, plus 1 upon m2 dm2 dt plus 1 by 2 1 upon m1 dm1 dt, and this is like 1 by 2 1 upon r dr upon dt. Fine. So this else will be equal to 0 because we have shown that this is a classic this is a classic central force motion. So dl sys dt, this guy has to be equal to 0, and this guy is equal to dl sys dt k hat. So this guy has to be 0, right? So this is equal to 0. Okay, so this guy has to be 0. So 0, this is equal to 1 upon m2. Then you have a gamma with a minus sign because mass of m2 will decrease, and then you will have 1 upon 2 m1, and then there will be a plus gamma because the mass of m1 will increase, and then you will have a 1 upon 2 1 upon r dr dt. Okay, so So if you do some jargon over this, so gamma upon m2 minus gamma upon 2 m1 will be equal to 1 upon r dr dt, and your 2 will get multiplied over this side. So 2 gamma divided by m2 minus gamma upon m1, this is equal to 1 upon r dr dt, right? So now if you simplify this expression, so this will turn out that if you take this gamma common, and then if you multiply, if you take gamma by m2 common, and then you will get 2 minus m2 divided by m1, this is equal to 1 upon r dr dt. So this is the thing. Now the thing is like m1 is much greater than m2, so 1 will be much greater than m2 divided by m1. So so this 2 minus this can be written as gamma m2 into 2, that is equal to 1 upon r dr dt. Fine. Now this is the answer for this particular question. Now there is a negative sign. There is a negative sign because the reason is the following. So reason is the following. So there is a negative sign. There will be a negative sign because a drdt will decrease, and why this will decrease I will explain just in a while. So this is m1, this is m2. So if this m2 loses mass, so after a certain time its velocity will drop down, right? Sorry, its mass will drop down, right? So that's why the gravitational pull will decrease. So this g m1 m2 divided by r square is your m v square divided by r, right? So because of the gravitational pull, if this so m2 will cancel, r will cancel, and then g m1 divided by v square is equal to your r. Okay, so let's say this r will definitely decrease, because as soon as this m2 will lose mass, it will just start spiraling and spiraling, and that's why there will be a time when this m2 will fall on m1. So that's the complete discussion of this problem, and the answer is, if you check the question paper, the answer is minus 2 gamma divided by m2. Yeah.